a video which gives the information about Newton-Raphson load flow analysis technique. If you see this problem, we have to calculate x and y at the end of 2 iterations by Newton-Raphson method, given 2 equations with initial solution also given for x and y. This problem can be solved using Newton-Raphson method. So basically Newton-Raphson method is an iterative method. In all the iterative methods, to find the unknown variables, we have to assume the initial values for the unknown variables. In this problem, it is clearly given the initial values are given. So here initial values are given. So we have to find the x and y values at the end of the 2 iteration. So solution goes like this. So we have to find at the end of first iteration the value of x. So the initial value we have to consider plus this initial value is not the final answer. So we need some correction for this. Let us mark that correction as delta x. Similarly, we have y. So y at the end of first iteration is y1. So the initial value of y1, y of 0, initial value, that is 0 is nothing but 0th iteration initially, y of 0 plus delta y. So these equations, let us call it as equation 1 and 2. So to find the values of delta x and delta y, we will use the formula in NR method, that is B is equal to JC. This is the formula for NR method. Let us write this for a given mathematical equations. So B is the correction vector, that is delta F1 delta F2 is equal to, so we have the correction for x and y, that is delta x and delta y. So this is dou F1 by dou x, dou F1 by dou y, so dou F2 by dou x, dou F2 by dou y. So this is equation number 3. Here we will assume the first equation, whatever they are given, is F1. Actually F1 is a function of x and y. This is y square minus 4x minus 4, and we have the one more equation in terms of x and y, that is 2y minus x minus 2. So these 2 equations are given. So these 2 equations we are using in equation 3. So if you know the values of this B matrix and this J matrix, by knowing these 2 matrix, the elements of this C matrix you can find. So what we do here is, let us find the B and J matrix elements. So one after the other. Let us find the B matrix element delta F1 and delta F2. So delta F1 is nothing but the difference between the specified quantities and the calculated quantities. This is the formula. So they are not given any specified quantities with respect to the function, and F1 formula is given. F1, see here we have F1 equation. This equation we will consider, that is y square minus 4x minus 4. So this is 0 minus, here we have to, initially we know the values of x and y initially. So y of 0, they are given it as minus 1 square minus 4, x of 0 they are given minus 1, y of 0 is plus 1. So whatever they are given I am writing. So this is nothing but minus 1 minus 4 minus 4. The answer is minus 1. Similarly, you can find the delta F2, that is F2 specified minus F2 calculated, F2 specified is 0, F2 calculated is, they have given F2. See here, as I showed before, here F2 is given. So, this you have to write here, that is 2y minus x minus 2, it is given. Here initial values we have to substitute. So, substitute these initial values, you will get 2 into y of 0 is 1 minus x of 0 is minus 1 minus 2. If you simplify this, you will get minus 2 plus 1 minus 2. This is also minus 1. So, delta F1 is coming minus 1, delta F2 is coming minus 1. So, in this as you observe, so we found the B matrix elements. Here it is required to find the individual elements of J matrix. There are 4 elements. For finding this delta F1 by delta x, what we do is F1 equation is there, no, that you partial differentiate with respect to x. So, you will get that. So, I will write here. So, F1 equation I will write, F1 is equal to y square minus 4x minus 4. Here we have to partial differentiate with respect to x and we have to partial differentiate with respect to y. So, let us see what we will get, 2y, that is all. So, this is with respect to x, so y 0, 0 minus 4, you will get minus 4. With respect to y, it is 2y, as you all know. So, here 0, so initial solution is y of 0 they are given 1, that is 2. Similarly, if you consider the second function, that is 2y minus x minus 2. So, you partial differentiate that F2 with respect to x, you will get minus 1. If you partial differentiate that with respect to y, you will get 2. So, here as you all know, so we are finding the 4 elements of Jacobian matrix, these 4 elements. So, we know delta x and delta B matrix elements, J matrix elements, and C is delta x and delta y. So, as you see here, delta F1, delta F2 both are minus 1. So, here let us write minus 1 minus 1, and here this is minus 4 delta F1 by this is 2, this is minus 1, this is 2. So, this is delta F1 by delta x minus 2, it is written. So, this you have to follow here. So, here we have no. So, same after calculating to substitute the first derivative elements of Jacobian matrix. So, by using any of the simple method, you can find the delta x and delta y. So, use any of the simplification method, you can find delta x and delta y. You will get from that solution, you will get these are the answers for delta x and delta y. Once you get the delta x and delta y, use this equation. See here delta x and delta y, initial values we know, substitute and get at the end of first iteration the values of x1 and y1. So, this is x of 0 plus delta x. See, x of 0 initially they are given in the problem minus 1. We found delta x is 0, this is minus 1. So, this is y of 0 plus delta x, delta y. So, y of 0 they have given 1 plus delta y value in the last. So, it is minus 0.5, minus 0.5. If you simplify that, you will get 0.5. So, this is the solution at the end of first iteration. Similarly, one can find at the end of second iteration the answer. See here, at the end of the second iteration, the equations becomes. So, at the end of the second iteration, we have to find x and y values. It is asked in the problem. This is x1 plus delta x, y1 plus delta x, delta y. So, here also you have to find the values of delta x and delta y, because x of 0, x of 1 and y of 1 are known. So, delta x and delta y you can find using the same procedure as adopted here, So, delta f1 and delta f2 it will remain same, this calculation remains same, only change here is, so here y of 0 is there, no, here you have to consider y of 1, here x of 0 is there, no, you have to consider x of 1, values are known. So, when you are doing the first iteration, initial solution they are given, it was x of 0 and y of 0, but when you are doing second iteration, initial values are not 0th iteration, previous iteration. When you are doing the second iteration, first iterated values we have to consider. That is why these changes you have to adopt. Here also y of 1 and x of 1, these changes you please do it. And here when you consider this here, this remains same, this remains same, this remains same, but here 2 into, write in different color, here 2 into y of 1 you have to consider, because you are in the second iteration, you should not consider 0th iteration. These changes you adopt and find the elements of B and J matrix elements. Once you know the B and J matrix elements, you can easily find delta x and delta y. So, you can write this. So, x of 1 and y of 1 are known. At the end of the second iteration, delta x value you will get 0.071, and here this is 0.5, delta y value will get 0.035. So, these two values are for delta x and delta y. Simplify that, you will get x and y values at the end of the second iteration. So, this procedure adopts the NR model, that is B is equal to JC. This is B is equal to JC. This matrix equation, if you remember, you can easily solve the two equations, two unknowns. But these two equations what we have are the nonlinear equations, they are not linear equations. So, you cannot do the procedure of simultaneous equation solution. Here you have to use the nonlinear equation solution, that is the method. Here we have NR method. So, NR method technique can be used to find the nonlinear equations. With this I will end the video. I hope this will be helpful for understanding the NR model and calculating the unknown variables using NR model. Thank you one and all.